Hello, water managers. My name is Simon Evans, part of the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to be covering HEC-FIA for swims today, part of the swims prospect course. This is the second part of 4 videos on this topic, and in this video, we will be covering the inputs to HEC-FIA. So the economic inputs to the FIA model form the foundation of the analysis. So FIA is a geospatial model, meaning that the inputs are georeferenced to the locations that they represent. So the main input required is a spatially referenced structure inventory. Structures, along with the associated population, are represented as point shapefiles. You can see in this image the little blue dots. The most widely used source for structure inventories in SWIMS models and throughout USACE is the National Structure Inventory, or NSI. So as I mentioned, in this image you can see an example of a structure inventory with the blue dots representing individual structures in the model. Early versions of FIA required the use of aggregated index points, so the georeference NSI is a huge improvement. Another input, economic input, is crop data. So crop data for agriculture damages for damage computations are added to the FIA model as geotiffs of the crop area. So the image here shows multiple crop types within a given area. Crop acreage can be downloaded from the National Agricultural Statistics Survey. So we also need some non-geospatial data, and that's necessary to support the geospatial input elements. These include stage damage functions for structures and content, crop production functions, as well as consequences at flood thresholds for critical infrastructure and impact response curves. So the national data sources available for both agriculture and structure data are shown here. If developing a new model, these are the best places to start, but it is always best practice to see if the district has more refined data available. In many cases, a calibrated structure inventory may have already been developed for a dam break study or through the USACE Rapid Inundation Map program. These can be easily incorporated to improve and update your SWIMS FIA model. So for agricultural data, the NASS has a web tool to download crop data for a given region. The user can then select the crop types that are important for the given watershed. Developing crop production functions can be pretty time intensive, so it's recommended to only import the most valuable or widespread crops for the given area. Data includes planting season information, value of crops, as well as a duration a crop can withstand an inundation. So the amount of damages incurred can vary greatly depending on the time of year. For example, in January, maybe a flood causes minimal crop damage since it's before planting season. However, a major flood a week before harvest would incur significant damages. As mentioned previously, the NSI is the USACE data source for structure information. It's based on HAZAS data, and major improvements over the years have been made by the NSI team, and it's made it into a great product to use within our SWIMS models. The NSI is usually updated every few years, and issues that were common in years past, such as structures found directly in the river, are much less common today. Another point is the terrain used within the FIA model should be the same terrain used by your HEC-RAS model in the SWIMS watershed. It's recommended practice to refer to the terrain within the RAS folder and not to have a separate copy of the terrain within the FIA folder for the SWIMS watershed. This can significantly reduce the size of your SWIMS watershed if there are not multiple copies of the same terrain. an FIA can link directly to that RAS terrain. So the second main source of inputs to an FIA model are the hydraulic inputs used to determine the depth of flooding throughout the model extent. So these sources include HEC ResSim output, including flow and stage hydrographs at common computation points. These are still used in some cases, but the majority of FIA models have been converted away from this setup in favor of gridded data from RAS. However, it is still an option available within FIA. And as I've alluded to, the main source of hydraulic inputs for FIA are from HEC RAS. These include gridded data, and that is made up of max depth grids, arrival time of inundation, and duration of the inundation. Also, for life loss calculations, you can have the max depth times velocity as well. FIA can also use DSS stage hydrographs at specific locations, specific cross-sections. This is the main input source for the impact response tool, which we'll talk about a bit later. And so different types of hydraulic inputs are required for different FIA outputs. So the direct damage calculations for structures need the maximum stage at each structure. Agriculture damage also requires the timing and duration for crop areas. Loss of life requires the arrival time at 2 feet of depth, as well as stability inputs at structures. And critical infrastructure and impact response, as I mentioned, require the hydrographs at locations of interest. So how does FIA use this hydraulic input data? Well, we're going to start with a quick overview of a hydrograph. So hydrographs are defined at common computation points as well as at cross sections, and it provides the timing of stages or flows at a location during the event. So if you have an important threshold, then you can calculate the arrival time. So the time the water arrives at that certain, compared to that certain depth threshold. The duration, so how long water is above a certain threshold, and that's used for the agriculture computations. And then, I think, as I mentioned, the max depth. So that's relative to an important elevation. So FIA would use, that could be like the first floor elevation. So the height above that, or the depth above that. And I mentioned that the underlying terrain plays an important role for applying the hydraulic input to the consequences. So this is why it's highly recommended that the terrain used for the RAS model is referenced in the FIA model. So how do stage hydrographs work? And I'll briefly touch on this, but it is highly recommended to use gridded hydraulic output instead. This option, stage hydrographs are still available in FIA, but it's not considered best practice because we have readily available gridded output. So stage hydrographs at common computation points use linear interpolation of stage between the max depth between two cross-section locations. So in this example, you can see the water surface. The max depth is taken off those two hydrographs, and then a linear interpolation is determined between them. And so FIA determines that water surface at each structure in between the cross sections. So it's just a linear interpolation. And it's subjected to some limitations, so it can provide a poor result if there's significant elevation change throughout between the two cross sections. And so cross sections are also recommended replacing with gridded data for the same issues mentioned with common computation points. And cross-sections can be thought of as very close together common computation points. So it's kind of the same process, it's just have many more, and you have the linear interpolation between them. So, for example, we've got these two cross-sections with the structure right in the middle, and FIA determines the structure height and the foundation height. And then using the two hydrographs for the upstream and downstream cross-section, we have a water surface interpolation. And then we can find, for this event, the max depth at that structure. Storage areas have a single stage hydrograph, but the structures can be at different elevations within the storage area. So therefore, each structure will get a different max depth. So we've talked about common computation points and cross-section hydraulic input, but it's really recommended these days to use gridded output from HEC-RAS. So the main hydraulic input source for SWMS FIA models are max depth grids from HEC-RAS unsteady simulations. The RAS simulations can also provide arrival time and duration grids among other output grids. So the gridded data can provide those same parameters. However, it's a more accurate way to compute depths across the entire flooded area instead of just relying on interpolation between cross-sections. And all FIA gridded hydraulic output or input can be generated using RAS Mapper, and that's accessed through HEC-RAS. And impact response and critical infrastructure locations do still require hydrographs, but only at the locations of interest. The most recent data source introduced as an input for FIA is the ability to use the native HDF RAS output directly. And this is possible in FIA using the RAS HDF inundation configuration. And we'll talk about that in a later lecture or video when we discuss flood damages reduced within FIA. So in summary, H&H inputs consist of either gridded data, such as max depth grids, arrival grids, and the grids of the duration of flooding. Max depth is used in the structure damage computations, while arrival time and duration are used within the agriculture damage computations. And the most common source of the hydraulic inputs are, as we mentioned, from HEC-RAS unsteady simulations. And you can see here that stage hydrographs are also an input source and can be output from ResSim or HEC-RAS cross-sections. This concludes the second part of the HEC-FIA SWMS lecture. If you have questions about our software, need some help, or are looking for additional training, check out these links. They also can be found in the description below. Thank you for your time.